Hey guys, welcome back. Mike Cosmic Creations here in Albany, Georgia. Going to show a quick video. I've got it dark because we're getting ready to bench test a set of wheel lights that I just finished. These are going out to a customer tomorrow along with the rest of his order. These are 4 rows of our insanely bright and high-powered 96 count lights. For those that don't know, almost all your other vendors sell what we call a 60 count light. That is 60 LEDs per meter. We sell the 96 LEDs per meter and the 144 LEDs per meter for about the same price, sometimes even less than some of your other vendors out there. So be sure to check these out. Very, very bright, very, very popular because of their intensity. We're gonna get the tablet set up. We're gonna power up a controller here in a minute to turn these on. Got the power supply turned on and set up. 14.5 volts. That's on the high end because when you're running your vehicle, your slingshot, whatnot, depending on your regulator and your current battery's charge, 14.5 is about the max you should be getting. Set at 10 amps total. So just from a quick QA/QC check, we can see that everything is working correctly as it should. We do this with every strip, every single strip that we make, because we want to make sure they work as they are intended to give you the best customer experience. You know, everything we do is custom and hand soldered. All our cables are handmade. All our controllers and amplifiers and power harnesses. You know, we put all that together and assemble it for you guys as a pre-package to help you guys during your installation process. Kind of see we're kind of bouncing all over the place here. I'm going to show you something interesting though. Constant voltage is holding at 14.5, but our amperage is bouncing around because our colors are changing. You're using different chips. Alright, 105. So on just red, and we can see it red because we see the background, that's pulling almost 10 amps. And we drop down a little bit in voltage. You're going to lose a little bit through consumption. You're going to have a little bit of voltage drop in your wires, your cables. So that's a little bit normal. But 140 watts there. Now this is, by the way, this is 4 rows each. So this is 48 feet of lights. 48 feet is what we're running off this one controller and amplifier. And we're pulling right at 10 amps. Looks like we switched over to constant current. And so really, really nice there. It's holding steady. I'm going to go to green. Green uses a little bit less. Looks like we're at 14.45. We came back up and dropped an amperage to about 9.9 amps. We're going to go to blue. Oops, sorry. So we went to blue. So same thing as red. Okay. Now here's the interesting part. So we know, or we should know, when you go to white turns all right, so each LED actually has 3 LEDs in it, red, green, blue, and through that mixture of different voltages to those chips we create whatever color we want. When we use white, it uses the most amperage, most current, most power of all the chips combined together. This is where a lot of people see problems at. Alright, now I'm going to go ahead and give you a heads up that unless you're doing reverse power injection, which you can do, this is typically going to be too much amperage for one amplifier. In other words, 50 feet on 1 amp, where these guys, if I'm not mistaken, they're 23 watts a meter. Alright, and you're going to see some voltage drop. With voltage drop, you can get some irregularities. You can get flickering, flashing. You can get odd colors. You can get colors that aren't true. You can get them not as bright. Okay. So I'm going to switch over. You see where we're at right here. And you drop down to 9.75. All right. And I can tell you, I want you to look at these. I don't know if you can tell or not. These are not a bright white. they're a dingy white. And we have these on what we call cold white. This is warm white, this is cold white. All right. But what we're going to do, we're going to disconnect. Oh, you see that color change in the background? See your voltage went up. And we're going to pull one more set. Oh, I got a bad connection too. So when you get flickering, strobing, things like that, that's indicative of a bad, poor electrical connection. It could also be low voltage, but we know that's not the case here because we're at 14.5 volts. So I'm gonna try to one-hand this. In fact, I'm gonna pause it real quick so I can two-hand it. I'll be right back. All right, so came back, and so with just white, with just one set. Okay, these are much brighter white. They are a cold, very bright white. They're not that dingy white like we had a while ago. And we're running 14.5 volts. Okay, it's almost 7.5 amps just on that one wheel because we're using all these at the same brightness. All right. Turn them down and you see your amperage drops. Okay, hold this with the other hand. I'm going to bump it up. So we turn down the brightness. We know we're not pulling as much current because the lights are dimmed down. Look at that. So hopefully this gives you an idea of voltage drop in how lights require power. That power can be provided lots of different ways through power injection. It can be provided with power harnesses, which is what we use. The new amplifiers that we have are rated for 20 amps. We took the standard amps and we had them beefed up. We also made them fully waterproof. You'll see those in some of the other videos. But hopefully this guy kind of gives you an idea of power consumption, power requirements, some of the offsets, negative offsets you can have if you don't have enough power, and just to give you an idea of brightness. So, thanks for watching. See you guys on the next video. Appreciate all your love and support.